Now we're going to talk about refraction, and here's a graphic showing some refraction. This is a glass of water with a straw in it, and you can see the bend or the apparent bend in the straw. The straw is in this orientation, but when you look through the surface of the water, you see it in another orientation. It appears to be bent. And you also see down here through the glass, because of the curvature of the glass and the water, you see some magnification. The straw is fatter in this region than it is up here. So, and the bending and the change in size, both of those are due to the refraction of the light. When you look at this straw, your line of sight goes through the water to see the straw there, or through the glass to see the straw there. And in either case, that light is coming from that part of the straw through the water or the glass and into your eye. And when light travels from one material to another, it often bends like that. And the bending of light when it travels from one material to another is called the refraction. The bending or the changing in direction, that's refraction. And I'll explain to you why refraction occurs. Here's a diagram that's very common, just showing basic refraction. This is supposed to represent a piece of glass. The green rectangle there is a piece of glass. So this is glass, and out here is air. In other words, all around here is air, and then inside this is a solid piece of glass. And glass is transparent, light can go through it, and we have a light ray striking the glass. And when it enters the glass, it bends, it changes direction. So if we were to draw a normal right here perpendicular to the surface, we get two angles, and the angles are always measured relative to the normal. This angle is the angle of incidence, and we commonly represent it with the letter I, and this angle down here is the angle of refraction. Commonly represented by the letter R. Now, why does the light bend when it goes into the glass? You can understand that if you understand that light changes speed. Now, the speed of light is a constant, and that's one of the fundamental constants of the universe. And we've learned that the speed of light, c, is 3 times 10 to the 8th meters per second. Specifically, that is the speed of light in a vacuum. And by vacuum, of course, I mean empty space, going through nothing, not like a vacuum cleaner. That's the speed of light in empty space, in a vacuum. In other materials, light typically slows down. So when it goes into the glass, it slows down, and that slowing causes it to bend. Now I'll try to explain why light bends when it slows down as it enters the glass. When you're drawing a diagram, there's a lot of ways you could imagine drawing a light wave. You could just draw a ray of light, a beam of light, like I've been drawing. That's like a beam of light coming out of a laser. You could draw an individual little particle traveling along, and we've called individual particles of light photons. So you could think of it as a photon. Sometimes people draw a little sine wave with an arrow on it like that, and the curve there, the little up and down sine wave, indicates that light is a wave. You could also draw it as wave fronts advancing, kind of like we did when we drew diagrams for the Doppler effect, and we imagined these sound waves advancing along in one direction, but we thought about the little wave fronts and the distance between them and those sorts of things. So you could represent a light wave in a diagram in a variety of ways, and in some cases it makes sense to use one representation, in other cases it makes sense to use another. When we're talking about refraction, if you want to measure these angles, the angle of incidence right there, or the angle of refraction right here, it makes sense to think of the light as a straight beam of light, these little rays of light. But if you want to understand why refraction occurs, why the light slows down when it enters the glass, that's most easily seen if you draw the wave fronts. So imagine this light ray as consisting of wave fronts. This would be kind of like waves approaching the beach. If you have the beach here and you have these waves coming in, you don't picture this as a ray coming in. You picture it as the wave fronts, the individual long wave fronts approaching the beach, roughly parallel to each other. So picture these light rays coming in toward the glass as wave fronts. Now, when the light enters the glass, it slows down, so you can see that this end of this wave front has entered the glass first, so it slows down a little bit. These out here are still moving at the speed of light until they're in the glass. They're moving at the speed of light in air. Once they're in the glass, they slow down, so they don't move as far each time now. And the light ray has bent. So you can picture something moving along, and then this side of it getting snagged here, and this side continuing to move at the same speed. So it ends up bending as it comes into the light, as it comes into the glass. Now this ray of light comes on out the other side and bends again, and the opposite happens. When these wave fronts emerge from the glass, inside the glass they're still traveling relatively slowly, but when they come out they pick up speed, so they move a little bit farther because they're moving at higher speed. And the light ray ends up bending again. Okay, not a perfect diagram, but I think you get the idea. The change in speed causes one end of that wavefront to slow down when it enters the glass, causing it to bend, and it causes one end of the wavefront to speed up before the other as it emerges from the glass, causing it to bend back. So that's why the refraction occurs. Refraction is the bending of light when it goes from one material to another, and it happens because of the change in speed. Light goes at different speeds in different materials, and the change in speed from one material to another causes the bending, causes the refraction.